Hello friends, in this video we are going to solve get numericals based on DFT, that is discrete Fourier transform. Let us begin. First question from GATE 2010 is displayed on the screen. It says 4-point DFT of real discrete time signal x of n of length 4. So from this, first of all, let me note down. I got the value of n, which is equal to 4. Secondly, it is given by x of k, that is DFT of x of n is x of k, of course. So since it is 4-point DFT, x of n having independent variable n is varied from 0 to 3, and of course when I'm saying x of k, which is DFT form of x of n, so k is also varied from 0 to 3. Then it is given as x of 0. So see to it carefully, this x is a capital 1. So what they have given you information of x of k. So the first information x of 0 is 5. I'll put an arrow mark here. Then we have x of 1 as 1 plus 1j. Fine. Then we have the value of x of 2 as 0.5 and the value of x of 3 and small x of 0 they are asking you. So please understand, this is missing. This is missing. This is called as capital X of 3, and what they are actually asking you, small x of 0. Please try to understand, small x of 0 means x of n at n equal to 0. So two values they are asking you respectively, and they have provided you some options also. So first of all, I'll try to get x of 3 from the given information of x of k. As we have already learned in last video lecture, that is x of k is always equal to x conjugate of n minus k. I hope you understood this. See, you know what? The value of n is equal to 4 given. So n is equal to 4, which is given. Tell me, which value is missing? Value of x of 3 is missing. What does that mean? If you want x of 3, let us get the value of x of 3. It means you are substituting the value of k to be equal to 3. So k value equal to 3. So this is equal to x conjugate of, what is n? N value is 4 minus value of k is 3. So can I say it is simply equal to x conjugate of 1? What does that mean? X of 3 by property is always equal to x conjugate of 1. Look at x of 1, it was 1 plus 1j. So conjugate of it becomes 1 minus 1j. What does that mean? The value of x of 3 that they are asking you is 1 minus 1j. Is that right? So let's see the options. You will understand that option C and option D are eliminated, and the computation is between option A and option B, and the correct option would be selected on the basis of value of x of 0. Please understand, this x is a small x, that is x of n at n equal to 0. So we'll use a central ordinate theorem here. So what was central ordinate theorem? Let me remind you. In fact, I'll derive it for you again. If you remember the formula of inverse discrete Fourier transform, please never ever get confused between discrete time Fourier transform and discrete Fourier transform. They are different, you know that. So the formula is x of n is 1 upon n, where k is varied from 0 to n minus 1, x of k e to the power j 2 pi by n nk. Is that right? So that was the formula of x of n. So inverse DFT, that is discrete time Fourier transform, that is inverse discrete Fourier transform, helps you to get the value of x of n from x of k. So this tool helps you to transform x of k back to x of n. That is, you are approaching reverse way, that is frequency domain to time approach now. So tell me, at n equal to 0, why I'm saying n equal to 0? Because I want x of 0. So I can say x of 0 is equal to 1 upon n, where k is varied from 0 to n minus 1, x of k as it is. Try to understand, when I say n value equal to 0, so here we have n, it becomes e to the power 0, which is 1. So this is x of 0, and this is what we called as central ordinate theorem. Am I right? Now here, the value of n equal to how much? It is 4, because it was a 4-point sequence, because they have said it is 4-point DFT. Am I right? Yes. So I would say x of 0, it's simply 1 by 4, where k is varied from 0 to 3, x of k, or I can now expand it like this: 1 by 4 in the bracket x of 0 plus x of 1 plus x of 2 plus x of 3. Is that right? Now this is equal to 1 by 4. Now let's get the values of x of 0, x of 1, x of 2, and so on. So the value of x of 0 is 5 plus 1 plus 1j plus x of 2 that they have given as 0.5 plus, if you remember, x of 3 wasn't given, so it is what we have obtained as 1 minus 1j. So here 1j minus 1j gets cancelled, so it is 5 plus 1, it is 6. So this is 1.5, so it is simply 7.5 divided by 4, comes out to be 1.875. So value of x of 0 is simply 1.875. Let us verify. So 1.875 is there in only option A, so even option B gets eliminated here. Option A is the correct option. I'm sure you got this problem. So what we have used here, a simple property which I have star marked it, and a central ordinate theorem, and this has solved our problem very easily. Let's move to the next question. 3 DFT coefficients out of 5 DFT coefficients of a 5-point real sequence. It means a very first thing that you must understand, n equal to 5. It is 5-point DFT, out of which they have given you 3 DFT coefficients: capital X of 0, capital of X of 1, and X of 3, and remaining 2 values are missing. So let me just write what they have given, and then I'll proceed with the question. So x of 0 is equal to 4, comma, x of 1 is 1 minus 1j, comma, x of 2 is missing, let me just put a blank mark, x of 3 given, it is 2 plus 2j, and you know what, even x of 4 is not given, so I'll put a blank mark. This is x of k given to me, and what in return they are asking you the value of x of 0. So what they are asking you, the value of x of 0, and of course for x of 0 again I'll follow a central ordinate theorem. But then to go for central ordinate theorem, each and every element of x of k first of all must be known to you. Am I right? So again, let me just write my x of k, what they have given. So it is 4 comma 1 minus 1j, then x of 2 was missing, x of 3 is 2 plus 2j, and again x of 4 is missing. So by property we know that x of k is always equal to x conjugate of n minus k. Please don't forget, here the value of n is equal to how much? It is 5. So which value is missing? It is x of 2. It means I am substituting k value equal to 2. Then this is equivalent to x conjugate of, please understand, value of n to be 5. So it is 5 minus 2. So it is x conjugate of 3. And you know what x conjugate of 3 is? 2 plus 2j. So it becomes 2 minus 2j. So value of x of 2 is now known to you. It is 2 minus 2j. One more value is missing, that is x of 4. So let us substitute value of k equal to 4. It becomes x of 4, which is equal to x conjugate of, try to understand, it is n minus k. Value of n is 5, k value is 4. So it is x conjugate of 1, which is known to you. So x of 1 is 1 minus 1j. X conjugate of 1 becomes 1 plus 1j. So you know what? Each and every value of x of k is now known to me. Now let me write central ordinate theorem. What you want is x of 0, which is 1 upon n. K should be varied from 0 to n minus 1. X of k. Is that right? Now this is equal to 1 upon n value equal to 5. And in the bracket, what we have is x of 0 plus x of 1 plus x of 2 plus x of 3 plus x of 4. Now this is equal to 1 by 5. Let's substitute all the values. So it is 4 plus 1 minus 1j. X of 2 is 2 minus 2j. X of 3 value is 2 plus 2j. And finally x of 4 that we have is 1 plus 1j. See to it. These things gets cancelled. Just solve it. You'll get x of 0 value equal to. So let's see the options. So value of x of 0 is 2. Option B is the correct option. Let's move to the next question. So what we have here, 4-point discrete Fourier transform of a discrete time sequence 1, 0, 2, 3 is. It's a very straightforward question. What they have provided you is x of n. What they want is DFT. So what they have given is x of n, which is 1, 0, 2, 3. And what they want is x of k. So what they want is a DFT form of x of n. So let me tell you, of course, if you actually refer a formula of x of k, and if you go on following the formula and if you go on expanding the formula, it is going to take your time. I don't say that you won't get the answer. Of course you will get the answer, but there is absolutely no way to waste your time. So what I'll do is I'll use a little bit trick to solve this. So in previous video we have seen, if I let's say substitute k equal to 0, you know that it is x of 0, which is always summation of x of n, where n is varied from 0 to 3. In this case it is from 0 to 3 because it is a 4-point sequence, am I right? If it would have been a 5-point sequence, I would have varied my n from 0 to 4. So this property we have already seen. And from where we got this property? Of course from DFT formula. In DFT formula, when you substitute k equal to 0, you get this. It is x of 0 plus x of 1 plus x of 2 plus x of 3. So just go on adding 1 plus 0 plus 2 plus 3. It is equal to what? It is equal to 6. And if it is equal to 6, then of course option A and option B are eliminated there and there only. Am I right? Also, since it is a 4-point sequence, you can use the property of x of n by 2 property. So if you remember, x of n by 2 is always summation n equal to 0 to 3 minus 1 to the power n x of n. Or to tell you in a very shortcut way, it is nothing but subtraction and addition of x of n sequences. That is alternative subtraction and addition of the sequences. That is what we had over here is 1, 0, 2, 3. Let's perform alternative subtraction and addition respectively. Then this is equal to 1 minus 0 plus 2 minus 3 this way. So it comes out to be 0. So value of n was 4. So x of n by 2 is nothing but x of 2. So x of 2 comes out to be 0. Now see to it, a competition was between option C and option D. So select only that option in which x of 2 equal to 0. As you can see, the only option D which shows x of 2 value to be correct one. Therefore, you did not to solve for other values. Option D is the correct option. So even option C gets eliminated from this. So that's what I keep saying, that if you know the formulas thoroughly, then it is easy for you to solve the problem very quickly. Thank you.